Good day everyone, I am Angelica Magcalayo and I'll be presenting our Capstone Research entitled The Role of Climate Change in the Increasing Frequency of Wildfires. This is a global issue and the data clearly shows that climate change is not just a background factor, it's a direct driver.
Our abstract. Wildfires today are more intense, frequent, and widespread than in the past. Our study highlights the role of rising temperatures, prolonged droughts, and changing weather patterns, leading to devastating effects of ecosystems, human health, and the economy. But we also explore possible solutions like land management, early warning systems, and international policy cooperation. Our introduction. Climate change is altering global weather patterns. We now have hotter, drier conditions, which increase the likelihood and spread of wildfires. In regions like California, Australia, and Southern Europe, fire seasons start earlier and last longer. And this is a feedback loop. Wildfires release carbon into the atmosphere, which worsens global warming, leading to even more fires. We had five goals in this study. First, to explore the role of climate change in relation to the increased growth and intensity of wildfires across the world. Second, to identify regional variations in wildfire patterns related to climate drivers. Third is to investigate the environmental, health, and economic effects of increased wildfire activity. Fourth is to emphasize the issues of wildfire control and prevention. And the last is to develop mitigation and adaptation methods based on scientific research.
Now let's move on to the key findings. So, what did we find? Fire seasons have lengthened in over 25% of the Earth's vegetated areas according to Jolly et al. 2015. Suppression efforts can keep up with this pace, especially during heat waves and droughts. And unless we cut emissions, UNEP predicts 30% more extreme wildfires by 2050 and 50% more by 2100s. And this is the projected increases table. To put that into perspective, by 2030, wildfires may rise by 14%, by 2050 it rises into 30%, and by 2100 we could see a 50% increase in extreme wildfires event globally. And this is the environmental impact. Wildfires contribute billions of tons of carbon dioxide annually, comparable to some industrialized nations. Fires in tropical and boreal forests, along with peatland and permafrost burns in Canada and Siberia, destroy carbon sinks and make climate goals harder to reach. And in terms of health impacts, beyond the environment, there are major health risks. According to Red et al. 2016, wildfire smoke increases respiratory and heart diseases, especially in children and the elderly, and those with asthma. With longer and stronger fire seasons, the health burden will grow. Now let's move on to mitigation strategies, and there is a hope. In Australia, they use controlled burns. In North America, indigenous fire stewardship supports ecological balance, and the UE is cutting emissions under the Paris Agreement, while the US is using AI and satellite system to detect fire risk. And countries like Spain and the US are investing in fire-resistant buildings. Here you can see how satellite early warning systems work. They use thermal imaging, vegetation dryness, and AI to predict high-risk zones days in advance, improving preparation and response time.
In conclusion, climate change is undeniably fueling wildfires. Regions once considered fire safe are now high risk. Wildfires are no longer just a seasonal threat, they're a year round danger in many places. The solution lies in reducing emissions, improving land management, embracing technology, and pushing for global cooperation. Without swift action, the fires will only grow. Thank you for listening. The sources for this presentation include works from UNEP, the IPCC, and peer-reviewed research.